This is Phil Woolery with Purdue Extension, and today we're going to be talking about interpreting soil test results for the garden. In the last video, we looked at different methods you can use to collect an accurate soil sample from your garden to ship out to the lab. And now we have our soil test results back. In this video, we're going to take a look at them and what all these numbers mean and some recommendations we can take from this report. So let's check it out. So here we have our results from our soil test. And on this paper, we have in this column here the kind of things that were measured in the soil test. And then here we have the results, so the values that they measured, and then kind of a rating of its very low to very high of those different things they measured. So we're going to go through these kind of line by line and kind of explain what each of them means. So organic matter. Organic matter is basically mainly the dead and decaying plant material in the soil. And it's very important for soils. As the material breaks down, it releases nutrients, which is important for plant growth. It also improves water holding capacity, so it makes your soil hold more water, improves aeration, so there's lots of pore space in there, so very good for plant growth. So that is what we have, and so the result, this is in percentage. So of the soil, we've got 3.9% organic matter, which is a rated medium. I think that's pretty good, given the fact that the soil is, I think, fairly sandy. So I think that's pretty good for this. Next, we have phosphorus, and this is measured in parts per million. So for every kind of million, if it's 1 part per million, so every million of particles, 1 part would be phosphorus. And phosphorus is used in many plant structures and in different biochemical pathways that the plant uses in its growth. And so we have 30 parts per million here, and it's rated as high. So we have plenty of phosphorus there. But it's not very high, so if a nutrient gets, we can have problems if you have too low of a nutrient, cause a deficiency, and if you have too much, we can have toxicity, so we're okay there. Next, we have potassium, also measured in parts per million. The symbol is K. That's from the periodic table. So this nutrient is used in water regulation in plants. So the stomata that open and close on the plant leaves that let in carbon dioxide, that also will let out water. So that the potassium is important in that sort of regulation. It's also used in protein and starch production. So if we have a deficiency, you could have signs of chlorosis or yellowing in older leaves and browning along the edges of the leaves. So in ours, we're at 26 parts per million, and we're rated at very low. So that's something that, it's probably a limiting factor in the garden. So we need to correct this to have good growth. Next, we have magnesium, again measured in parts per million. We have 200 parts per million, and magnesium is used in chlorophyll, which is kind of the pigment that plants use in photosynthesis, and also in many different enzymes within the plant. And this one is rated as high, so nothing's really needed for this nutrient in our soil. We also have the next nutrient is calcium, measured in parts per million again. And we have it at 1250. And so this nutrient is important in cell walls, strengthening that. So blossom end rot, which is common in tomatoes and peppers, can be caused by a calcium deficiency in plants. Calcium is also important in soil pH, and we're going to talk about that in a little bit too. So the next thing they measured is the cation exchange capacity. And this is basically a measure of the ability for the soil to absorb ions, like the nutrients we just talked about. So it's basically a measure of how well that soil can hold on to these nutrients. And this is going to be affected by the soil type we have. So soils that are higher in clay are going to have much higher cation exchange capacity than sandy soils, because those clay particles have lots of different spots where these ions can attach to and be held onto, as opposed to sand, which are much larger particles, which would have fewer, relative surface area there. So another thing, organic matter can help increase your cation exchange capacity there in your soil. So the value of 8, this is at low, and then we do have a fairly sandy soil, and so that's probably why we have that measure. The next is soil pH, and this is listed as 7.1. And pH is a measure of how acidic or basic a soil is. So at 7, is at neutral, and above that is basic, and below is acidic. And soil pH can affect some different nutrient availabilities in the soil. Vegetable garden, 7.1 is, it's listed as high, but it's within the acceptable range, so we're probably okay. And with calcium is higher calcium is associated with higher pH. So if the pH was low, we could add lime, which is a form of calcium. So adding both of those would, adding more calcium will increase your soil pH. So something to be aware of there. So here in this section, we have the annual nutrient requirement. So these are kind of the general recommendations, what we're going to need for these nutrients to grow a vegetable garden. It's listed in 2 kind of different rates. So pounds per 100 square feet and pounds for 1,000 square feet. So you can use either depending on the size of your garden. So we have the different ones. Lime, I mentioned lime is basically the calcium, and that'll affect your pH. And so they're recommending adding 0 lime. Nitrogen is the next one, and nitrogen actually was not measured. And there are soil tests you can measure nitrogen, but we generally don't do that, especially because the nitrogen is very mobile in the soil. So if you measure it in the fall and then see that nitrogen is there, but because rainwater can leach it through the soil, that nitrogen may not be there in the spring. So we just have a general recommendation of, 0.4 pounds of nitrogen per 100 square foot, or 4 for 1,000 square feet. And that should give us the amount of nitrogen needed to grow a garden. With phosphorus, we were at high, but I would say you could take it or leave it on that with the phosphorus, because we could probably grow a good garden with the amount of phosphorus we have, but it probably wouldn't cause any problems to add some more. And the potassium, listed as 7 pounds, we're very low on that, so we need a lot more potassium. Magnesium, we're good on that, so there's no need to add any magnesium. And then sulfur. Sulfur you add that if we need to lower our soil pH. So down here we've got some suggested fertilizer applications, and here we have this NPK, which stands for nitrogen, phosphorus, and potassium. Those are the 3 what we call macronutrients, the nutrients that the plant needs in the greatest amount. Not necessarily the most important, but what they need in greatest amount. So we have the 3 numbers here, and those correspond to nitrogen, phosphorus, and potassium. And this is all its percentage. So in this fertilizer, it's 12% nitrogen and 12% phosphorus and 12% potassium. So if you had a pound of this fertilizer, it would, in that pound, or 10. So if we had 10 pounds of this fertilizer here, in that 10 pounds, we'd have 1.2 pounds of nitrogen and 1.2 pounds of phosphorus and 1.2 pounds of potassium. And the rest is kind of sort of fillers that help it form, be more in a stable form, which it's not nutrients. So here they're recommending adding that. So it works out to there. So if we do the math, we have 3.3 pounds per 100 square foot, or 33 pounds for 1,000 square feet of this. And that will get us out to, if we multiply that 33 by 0.12, that would get us the pounds. So it would give us around roughly 4 pounds of nitrogen, 4 pounds of phosphorus, and then 4 pounds of potassium. But we need for this 1,000 square foot, we need 7. So we need to add additional potassium. So they recommend this kind of potash. So we see these numbers 0060. So it just contains the potassium. So no nitrogen, no phosphorus. So it gives the rate. We're adding 5 pounds of that per 1,000 square foot will give us the additional potassium we need to get that kind of back in balance. And then in the end here, we have some comments on here, and they're talking about applying only half of it right before planting or seeding, and then applying the rest afterwards. And that's kind of a good recommendation, especially something with nitrogen in there, because like I said, it's mobile. So if we put it all on at once and we get a big rainstorm, that can wash out that nitrogen, and we can kind of lose some of that. So adding that at different times, we reduce the risk of losing that nitrogen, and it also reduces potential, because if you add too much of a fertilizer, we can burn some of the roots there. So that was the results of our kind of basic soil test analysis. There are other soil tests kind of more in depth that you can have that will measure more nutrients and get kind of more in depth. So we'll measure some of these more micronutrients, things that are needed in lower amounts by the plant. And that could be needed if you notice a certain symptoms in plants that would lead you to believe that you might have a nutrient deficiency in one of those micronutrients. But here we have kind of the basic soil test results, and it has some good recommendations to help balance out soil. We have some things we need to improve, and it's a good idea to do these every couple years, checking if the soil pH and if we have any nutrient imbalances. And I also would see the change in organic matter, see how the practices of gardening are trying to increase the organic matter. So that'd be a nice thing to track over time. So if you have any questions about soil test results or soil fertility recommendations, you can reach out to me in the comments below or contact your local extension office. Have a good day.